We're going to start with this bottom one, and then we'll come back to the top for kind of a review of Friday. All right, triangle inequality, remember, says A plus B greater than C, B plus C greater than A, and then C plus A greater than B, or some version of that. And that's, of course, where we have 3 side lengths in a triangle. And it says any 2 of those have to add up to be greater than the 3rd side length. So in this one, remember I told you I start up here at the top left. You don't have to do that. It's good to have consistency. That's where I choose to start. So that's one of the inequalities. And then just work your way around the triangle, adding 2 sides and setting it greater than the 3rd side. And now I start on the 15. And it sets up 3 inequalities that you need to solve for x. Well, in this case. So if we solve this one, we get x is greater than 3. And I didn't show the little individual steps in there. Here's what they were. So combine like terms and then add 3 to both sides and then divide by 6 on both sides to get 3. The middle one, we'll combine those like terms and get 12. And then if we subtract the 4x, we get negative 2x on the right. And we can see that that one is going to yield a negative result. We do have to flip the inequality. Remember when you divide by a negative. But anyway, this is basically telling us that we could have some negative values that are okay, which we know is not okay. So this one is nonsense, meaning it doesn't tell us anything. All right, last one. Let's combine our like terms across the inequality symbol. So I'm going to subtract 2x and then add 3. And we'll get 9 there. So again, I just subtracted 2x, added 3, divided by 2, and we got 9. Okay, then we go set up our compound inequality. Stick x between 2 less than symbols. And we just do in order from least to greatest. So on the left, we put 3. On the right is 9. And this tells us that x can be between 3 and 9 in order to make that work out as a triangle. So how'd you do on that one? Raise your hand if you got 3 and 9. Okay, so we've done quite a few of these at this point, and this will be on your upcoming assessment, which we'll probably be able to get to by Friday. And this kind will be on that. If you're having trouble or struggling, you definitely need to come ask for help, because at this point we've done quite a few. Like I said, at this point it should be going well. This one is a little bit newer, so struggling on this one would be a little bit more normal, I think. It says find the perimeter. What does perimeter mean?
Outside.
Yeah, so distance around the outside. Which means obviously we need x. There's a lot of information in the picture. What information is useful? What do we need? What do we set up? All those things. What do we know about this triangle? What do we know about this triangle? First question, keep in mind at this point we've seen triangles a fair bit in our school year, Yeah.
Angle A and B are equal to each
other. Okay, so he's looking at what kind of triangle is this? And like I was saying, thank you, Isaac, you're correct, by the way. At this point, we've done a fair bit with angles and triangles and angle sums and that kind of thing. So we're specifically wondering how these side lengths relate so that we can solve for x. We can't make assumptions. Can I add these 3 up to 180? Is that okay? No, but that's a common mistake. So people see three things and they're like, oh, it's 180, and they just add things up to 180. But these are side lengths, and side lengths don't necessarily add to 180. But these angles inside do. So those two plus that angle, those do add up to 180. So what we can do is say, maybe just call this Z or something. So we have a variable there. And we can see what that Z angle might be. So then we can start answering what kind of triangle it is. Good morning. How's it going?
How about you guys?
We're a little quiet this morning.
I was gonna say, it's really quiet.
Yeah, that's okay. All right, so we find Z is 24, or angle A is 24. And what does that tell us in terms of kind of triangle? It's isosceles, yeah. So put the markings on there. It just helps with the little visual. And that tells us, well, the markings I just put on there tell us what's true. What can I do to solve? If it's an isosceles triangle and these two angles are congruent, those two side lengths are as well, and what? Nice. I'm going to write that since you said it. Okay. That's because of the fact that it's isosceles. Anyway, so we're just going to set two of these x pieces together instead of all three. And let's go ahead and solve. We'll get our x's on one side, get our constants on one side, and we'll get x to be 10. All right, that's the big bulk of the work. How do we get the perimeter from there?
Plug X in.
Yeah, we just go plug x back in, and we'll get 2 times 10 plus 15. Of course, we know the other side is the same, so we don't really need to plug x in over there because it's congruent. So this is 35, this is 35, and then down here, 4 times 10 plus 12 is 52. So our perimeter is 35 plus 35 plus 52, which is 122. Did anybody get that one correct? Nice. A couple of you. Okay, this kind of problem will be on your upcoming assessment as well. There are a lot of things being drawn into this problem. So if we name them triangle angle sum, so we had to know that all angles added to 180. That means, or that had to tell us that this is an isosceles triangle. From that, we needed to know that means two sides are congruent. From that, we needed to set up an equation and be able to solve it. And so then plug in to find perimeter. So that was 5 different concepts being brought into this one. Let's check your homework from Friday. I know not everybody finished, but we'll let you check what you did do. And let's kind of go through this as quickly as we can so we can move to the next topic. On this one, you should have got 60, 65, 115, 55, 120, and 60. Any questions on the first picture? Okay. That was kind of a combination of isosceles triangles, solving for angles with that, and then knowing what is every angle in an equilateral triangle? What is the degree measure? 60. And then you had some linear pairs in there as well. Number 2 is, I didn't write the answer on this one, is every equilateral triangle isosceles? What do you think? Here, let me draw my best equilateral. Is that an isosceles triangle?
No.
Yes, it is. Why? What is the definition of an isosceles triangle? Two sides are congruent. Does this have that? Yeah, we just get the bonus side that is also congruent. So yeah, it is. Actually, I'm going to leave that on there. Is every isosceles triangle equilateral? Nope. I mean, you could draw a super easy one that's clearly isosceles. Definitely not equilateral. Okay? All right, next ones. Number 3 is 80 and 50. Number 4 is 5 centimeters. Number 5 is 60 degrees. Number 6 is 88 and 46. Number 7 is 70 and 70. Number 8, 54 and 63. Number 9, x is 100, y is 140. Number 10, x is 52.5, y is 75. Number 11, x is 30, y is 120. Okay, flip. Number 12. So it says, explain why it's isosceles now. So if we find angle P and angle QRP, they're both 55. And so that makes this isosceles. And then number 13. X is 70, y is 55. 14. X is 90 and y is 30. 15. X is 35. 16, x is 12. 17, x is 10. 18, x is 55. Y is 70. 19, n is 30. M is 60. 20, n is 45. M is 65. 21, x is 4.5. 22, q is 44, and qr is 125, and y in that one is 94. 23, x is 21. 24, y is 120. All right, that was a lot. Any of them that you would like to do? Any that gave you trouble? Okay. Absolutely, these kind will be on your quiz, so on your upcoming assessment. Like any one of these versions is fair game. Although I will tell you that I don't put the super easy kind on there. It would be more like something like 19 might be on there, or 20. These kind that have kind of pieces of different triangles hooked together, so like maybe like 11 might be on there. So no questions on that? Okay, give me a fist of 5 on isosceles and equilateral solving, please. Okay. Probably a high 3 to roughly 4 average. Let me give you one in context to try. We're dealing with this problem, number 28. So I'll let you read that. The picture's there. I don't know if you can see the H. Let me highlight that a little bit better. So H is there. It is that height of the triangle. Anyway, I'm going to give you about 3 minutes to read through and solve that one and see how that goes. Anybody ever seen a big beam being lifted by a crane before? They generally do try to keep it level, so it's not like swinging around, and these things can be super heavy. It would probably kill somebody if it hit them. I had a patient actually in the ER that had a beam drop on him and he died, which was pretty sad, but so they try to be super careful with this. It tells us that this, just in the picture, that these two sides are congruent and these two angles are. And you can see this 90 down here. So what is that line called, the vertical line? Yeah, it's a perpendicular bisector. And if you read through the problem, it says the two support cables must form an isosceles triangle. Again, trying to keep those cable lengths the same so that it's not flying around crazy. It says the beam is 18 feet, so that's helpful to put on here. And the height is 8. What is the total length of the two cables? So height there is 8. And I guess you can't see the 18. Let me fix that. That's better. Okay, well, how do we find that? I would tell you to look specifically at one triangle, one half of the isosceles triangle. What kind of triangle is that? Yeah, that's a right triangle. And we know the height is 8. How long is the base of that right triangle? It's 9. Remember, the isosceles perpendicular bisector theorem says that base is split in half. So it's 9 feet. So how do we find the length of this cable? And once we know it, we know the other one is congruent, so we can just double for the total length of cable. But how do we find that x value? In a right triangle, how can we find lengths in a right triangle? I'll start you off. A squared. What's that called? That's called the Pythagorean theorem. So in this unit, we have used that to classify triangles as either acute, obtuse, or right triangles. So maybe we need to go back and review that. But which side has to be plugged in correctly? Yeah, the longest side, which is always the side that's opposite of the 90. So that's called the hypotenuse. Anyway, what letter does it always have to be? Yeah. So the hypotenuse is always C. The other two can be plugged in either order. So we know this is going to be x squared in this one. And then, like I said, 8 squared plus 9 squared is fine. Okay, 8 squared is 64. 9 squared is 81. And how do we solve for x? Like, how do we get x instead of x squared? Yep, just square root both sides. And in this one, we do want, even if it's a decimal, we do want the decimal because we're talking about a real life problem, right? We don't tell people, go cut me square root of 25. Well, that would make a whole number. Square root of 165 feet of cable or something. That doesn't work. So in this case, a decimal is okay. 64 plus 81. And so square root of 145 is 12.04. And what do we do to get total cable? Yep, so 24.08 feet in this case. All right, anybody get that? Is it because you forgot the Pythagorean theorem? Okay, we got to get that tool locked in. I mean, it just kind of sneaks its way in every now and then in a right triangle. We've got to be able to find lengths using that Pythagorean theorem. I just want to show you a couple of these others. We might come back to them, but you've seen a birdhouse probably in your life at some point. Notice that can make a isosceles triangle. Same with the tent, this kind at least. So these are common shapes. Of course, we know roofs. You know, we could just as easily think of this birdhouse as the gable on a roof, on a house roof. The gable is where the two pitches meet, and like our house has gabled windows and gabled ends of the house. So we have gables all over that are all isosceles triangles. They're like 1, 2, 3, 4. There's like 5 different isosceles triangle pitches in our house. Okay, I'll show you what I mean. I'll pull up a picture here in a minute. So this kind of stuff is definitely realistic out in the world. It comes up. All right, let's wrap that up. And we're going to move on to triangle congruence. While I'm handing out a sheet, I want you to answer this question with somebody near you. And be specific. I don't want you to say one word. Be kind of deeper in your analysis of that, because we're going deeper with it. So the better you do here, the easier that will be. talk to somebody. What is congruent? This yellow is the same as the different paper. All right, what'd you guys say? Okay. Shayla, what'd you guys say?
Two sides are the same.
Okay. How about you, Aiden?
Two variables and
Okay. Nathan, how about you? Okay. Nobody has said angles. Can they be congruent? What does it mean for two angles to be congruent then? How about you, Luz?
they're have the same value.
Same value. Okay. So what do you think, like we're moving into proving triangles are congruent? So everybody either said, just now, everybody said either a side length is the same length or angles are the same size. What does it mean though for a figure, like a triangle, to be congruent? Do you see how we're kind of expanding this definition now a little? Can it be shrinked and still be the same? Okay, but good thought. I'm glad you brought that up. So do we think it means same triangle? If we're saying congruent sides are the same length, then congruent triangles probably have to be what? Same size, okay. So we're expanding this definition a little bit. And go grab your notes and let's start putting that on here. Okay, so congruent figures, we'll get specifically into triangles here shortly, but congruent figures. So this is no longer just lengths or angles. It's like whole shapes, okay? So for an entire figure, think triangle. Like quadrilaterals. Anyway, like all these shapes and figures. So for an entire figure to be congruent, it must have, what do you suppose? Let's be super specific. Actually, I'm going to add a word in front of that. All if I stand right here, can you still see? Okay. Having trouble writing. There we go. All congruent corresponding angles. Corresponding means what in geometry? Yeah, kinda. Like in the same place in the figure. So on the same line. All right, and then Also, it has to have all congruent corresponding lengths. Let's say sides. We'll be specific there and say side lengths. So if I am talking about a side length AB, then whatever that corresponds to in the other figure, like wherever it's the same exact side length, it has to be congruent. Okay? So same angles, same side lengths is a quick way to say that. And what this boils down to is it has to be exactly the same shape and size in every way. That's what congruent figures now mean. All angles, all corresponding angles are congruent. All corresponding sides are congruent. Obviously, the shape is congruent. Everything about it has to be identical. Okay? Like a copy. So how do we know if two triangles are exactly the same? Do we need to measure 3 angles and 3 side lengths every time? That's really what we need to know. So specifically for triangles, I'm going to write this for mine. I'm going to put it right under here. Actually, I'm going to start the next page. When you're ready, go ahead and move on to that. So specifically for triangle congruence, is it necessary to show all 3 angles and all 3 sides are congruent? What do you guys think? That's 6 measurements, right? Is it necessary to prove that all of those are congruent in order to know that the triangles are congruent? Since we just defined it as exactly the same size, exactly the same shape, identical figures. Okay. So a big part of this section is learning that we don't actually have to prove all 6 are the same. There are combinations of 3 of them that if they are the same, then the whole triangle is exactly the same. And so it saves us a little work. That's good, right? And this sheet that I just handed you, I want you to look on the front side, which is the one with the bold letters. So most of you got a pink one. Some of you got kind of a yellow one. And those 5 things, flip yours over, Morgan, on the other side. Those 5 bolded, highlighted, no, Aiden, you were on the right side. Can I borrow yours? Is this side, please be on this side of it. Those 5 boxed, bolded, 3 letters, one of them has 2 letters. Those are the 5 ways that we can show that triangles are congruent. And notice that all of them have 2 or 3 letters, and that's it. That means we only need to prove that 3 out of the 6 are congruent, which is awesome because that saves us some work. So this sheet that I handed you is going to be a really important reference in terms of deciding if 2 triangles are congruent. Notice the top 2 have 2 side lengths, at least 2. The middle 2 have 2 angles, and then that bottom one, HL, is kind of the oddball. It does get used, though, occasionally. So don't just dismiss it, but the others probably, I would say, get used a little bit more. So why don't you highlight what I just pointed out? The top 2 are they have 2 side lengths at least. So I wrote on the left at least 2 congruent sides. Okay? So if you know all 3 sides are congruent, then the whole triangle is congruent to each other, even though we know nothing about the angles. But then we don't have to prove anything about the angles because we're sufficiently proven just with side lengths. Okay, on SAS, side angle side, please read carefully. It says if 2 sides and the included angle. So note that I said in between. Please put that on your paper. So the angle has to be in between the 2 side lengths. Anyway, if those are congruent, the whole triangle is congruent. We don't have to go measure the other 3 pieces. Here's a way to make sure you're in the right order. Notice we have a side length marked congruent, and then we loop around. There's our angle in between, and then we have the other side length marked as congruent. So that's how we read SAS, or side angle side congruence. So SAS. Okay, similarly, the middle 2, now they're angle heavy, meaning they have at least 2 congruent angles. So please mark that off to the side, 2 congruent angles. And the reason I'm having you point that out is because when you do proofs with this, you'll be kind of looking at which of these strategies you're going to use. And if you note that you have 2 angles that you know about, well, that probably means ASA or AAS, one of those 2 things. We'll come back and annotate some more on this tomorrow. Please look over it tonight so you don't come in just fresh on this tomorrow.